Oh, okay. Actually, you might have got it in there. You can poke your head in again.
You can just play through.
Shout out to Connor. Okay. This, I have to stand off to the side because the video. But this is all the cells for digestion. So we'll run through it relatively quickly because I decided to draw everything out. So here's your mouth, not your mouth. It could be your mouth. I'm a little concerned if you look like that. So you eat food, goes down your esophagus, and then it comes into your stomach. And we only care about 6 of the different kinds of cells that are found within your stomach that will help you start to digest all of the food. So the first one, I'm actually going to start with the really simple ones, the ECL cell. This one is really weird and really dumb, but it's fun fact. ECL stands for enterochromaffin-like cell. Entero means small intestine, and chromaffin is probably named after some scientist that found it, and then like is because it's like that cell, but isn't. Yeah, so it releases histamine. If you remember histamine from past stuff, like antihistamines, inflammatory stuff. The nice thing is, this is a paracrine. So we've got the endocrine, exocrine, and paracrine. Endocrine means it goes into the blood and then flows around the whole body. Exocrine means it goes into the lumen of whatever that space is. And then paracrine means it leaves the cell on the outside but doesn't go into the blood, and then just can travel in that interstitial space to whatever cell it needs to get to. So histamine is the only one that is a paracrine. Everything else will either go inside the organ or into the blood and circulate through the body. So there's the ECL cell. And then we have the mucus cell, which makes mucus. Surprise, surprise. This mucus, so it's a really thick layer of secretion that coats our stomach. This is why you don't get stomach ulcers unless you have the bacterial infection, the H. pylori. Because what those do is those burrow into your stomach and they start to destroy the mucus cells and the mucus, so then you start getting those ulcers along your stomach. Otherwise, you don't get stomach ulcers because this mucus protects you from that high acid. You eat food, so we did those 2 cells. You're going to activate these G cells. G stands for gastrin, probably like gastrin producing cell, because it makes gastrin. Gastrin is really useful. The cell is activated by ACH. ACH is the neurotransmitter for the parasympathetic nervous system, rest and digest. If you're trying to digest something, you're going to get more ACH, more secretions, more digestion, happy. You also get a basic pH. So what's happening is as you eat food, the food that's in your stomach is going to start pulling out protons from that hydrochloric acid that's in there, reducing the acidity, making it more basic. And then also stomach distension or stretch. If you eat a bunch of food, your stomach will stretch. Can only hold like 2 liters depending on how big you are and how much you've trained it. But like if you're me, my stomach is like itty bitty. I can eat a little bit of food and then it will just already start stretching. So then I'll get a bunch of gastrin. Gastrin is an endocrine hormone. So you can take a blood sample at your finger and you can detect levels of gastrin. It's going to leave there, go all over the place, and be a stimulatory hormone to every single one of the stomach cell types, including the D cell. So here in purple, I have my gastrin. It's going to go to all of these cells. It's going to cause your mucus cells to release mucus, the ECL cell to release histamine. The next cell we're going to talk about is the chief cell. So this one is really useful. So we talk about protein digestion and lipid digestion. Most of that happens inside the small intestine, but some of it does happen inside the stomach, but it's like super weak sauce. So we have pepsinogen, which is secreted as an inactive enzyme, activated by the HCl. We also get lipase, but that lipase is useless, so we don't care. Then we have the parietal cell. This one is super important. It is activated by, this is a big mess, so I apologize. Gastrin is going to activate it, and ACH is going to activate it. Both of those sympathetic and stomach actually getting food. The HCl, stomach acid, kill anything that comes in, and then intrinsic factor is super important. Intrinsic factor will bind to vitamin B12, and that is necessary, like required for you to make red blood cells. So if you have an issue with your parietal cells not having intrinsic factor, you'll start to get anemia because you can't make more red blood cells. And then we have the D cell. Actually, the D cell. This one's cool. It's activated by gastrin from the G cell and it releases something called somatostatin. Somatostatin is again another endocrine hormone, floats around and is going to basically put a brake on all of these so your stomach and digestion doesn't go into overdrive immediately upon getting food. That'd be really bad if you just start digesting everything in there. The parietal cell. I wish I had done that first. Okay, parietal cell, back to this stuff. This is how it makes hydrochloric acid. I have hydrogen ions in here, and I have this hydrogen potassium antiporter. Push hydrogen ions in here, and then I have a chloride leak channel where I'm also pushing them out. So there where I'm getting my hydrochloric acid. Got my sodium potassium pump as always. I've got a potassium leak channel. What I didn't draw on here, and I'll draw it on here now, is I've got receptors for acetylcholine, acetylcholine, gastrin, and histamine. So a lot of people who tend to struggle with like stomach ulcers, or what we say is stomach ulcers, but it's really duodenal ulcers, is we can give them drugs that will like block some of this stuff. But like the best drug that we found is called omeprazole, and it blocks this proton pump here. So if I block this, I don't get any more acid, which means any kind of ulcers that I was getting is going to stop. So no more ulcers. Omeprazole blocks this. Any questions about stomach cells?
So you're getting ulcers because the mucus cells aren't working.
If it's in the stomach?
In the stomach.
Yeah, and that's only because of the bacterial infection that's stopping these from working.
And then the acid comes in and it damages the stomach.
Yeah, because the acid will normally just start to break down the stuff. The mucus is there to protect it, but we don't have mucus cells in the small intestine, which is why you always get the duodenal ulcers.
So if you don't have like your bile, because isn't the bile what like buffers?
No, that's the bicarb from the pancreas.
Okay.
So if you've got pancreatic cancer, you'll probably also start getting a bunch of duodenal ulcers, because if the pancreas is out, then you don't release that bicarb, and then it won't buffer the acid that's coming in here. Okay, so now we have food that's gone through its thing, and now it's in the small intestine. I have an enterocyte. This is all of that carb, lipid, protein digestion that happens where I'm just moving everything into the blood. So the small intestine is made up of these SIKL cells, and then all of those other cells that do that reabsorption. So that's just what the enterocyte is. So I'm not going to go over that because that's a different video. Okay, so the different types of small intestine cells, because this is the majority of all of our digestion, and the way that I get that digestion started is usually by the activation of this I cell. Or we're going to start with the S cell because it spells sickle, and we like that. So the S cell, when I'm getting that stomach fluid in here, we call that chyme. And that's called chyme, which is that acidic solution of stuff coming in. So that acidic pH is going to activate these S cells, which release secretin. Secretin, again, all of these are endocrine. So all of these hormones are going to go into the blood and circulate through the body. Secretin is going to go to the pancreas, and the pancreas is going to release bicarb to buffer that acid that's coming in. It's also going to go back to the G cells and inhibit the release of gastrin. So I'm reducing the amount of stuff that's coming out here, especially because if I block this, I'm blocking this and reducing the acid that's coming in. So it's kind of like a double fold. I'm like trying to slow down digestion so I can work on what I already have. The I cell is going to be activated by any partially digested food, especially fats. Because CCK, which is what is released from I cells, stands for cholecystokinin. And cholecysto refers to the gallbladder. If you remember your like cystic duct, some fun anatomy. And then kinin means to move, because basically the gallbladder is going to have like these little pulses of pushing bile salts out into the lumen. And those bile salts help emulsify the lipids which is why fat is especially useful for activating this. The other thing that it does is it closes pyloric sphincter. This is my beautiful pyloric sphincter. Wraps around, closes it off. So now I can't get as much food coming in here, and that's reducing that gastric emptying. So one of the nice things is if you give someone a CCK agonist, this may not be real, I'm just making this up, but it'd be pretty cool. You can close this so then you stop overeating as much. Because if your stomach is full, it's going to be like, all right, you don't need as much food. You feel full. And that's coming from this CCK. So if you're giving someone a CCK analog, they'll feel full, go to your brain, you feel full, and it's also going to keep the stomach literally more full. So then you're not going to want to eat more. Pretty cool. And then the pancreas is going to release all digestive enzymes. And the reason I say all is that's your alpha amylase, that's your trypsinogen, your chemotrypsinogen, the carboxypeptidase, lipase, colipase, everything is because of that I cell. Make sense?
Yes,
cool.
Coach.
Great. K cell and L cell. These ones are cool. They're both activated by partially digested carbs. The K cell releases something called GIP1, and the L cell releases GLP. I should label both of these. I'm going to use not brown. We'll use...
I thought L cell was GLP-1 and K cells.
L cell is the GLP. It might be GLP1 and then it's just GIP.
Yeah, that's
That
what I
might be
have
what it
written
is.
down.
Yeah,
but I
me
could be
too.
wrong.
All right, cool.
Me too. I have that
We'll go
written
with
down
that.
as well.
That sounds good to me. I can never remember. Okay. So, both of these are called incretins. And what that means is just something that stimulates the release of insulin. So both of these are going to go to the pancreas, because again, partially digested carbs. If we have partially digested carbs, we're going to have an increase in blood sugar. So the insulin is there to lower that increase in blood sugar. And then the GLP-1 specifically also causes a decrease in release of glucagon. I should label this. I didn't. So I'm going to write it over here. If this is even... Oh, it is. Okay. So your pancreas is made up of 3 different kinds of cells. Pancreas cells. So you have the acinar cells, and those ones release your bicarb and digestive enzymes. And then you have alpha cells, and these ones release glucagon. And then you have beta cells, which insulin. Insulin lowers blood sugar through several fun ways, and glucagon does the exact opposite of insulin. And then GLP-1, this is a really useful weight loss drug that you'll often see. I've seen like ads on YouTube for like the hers or like Hims,
Yeah.
that kind of stuff. So the GLP-1 agonist, which is what those are, I think it's semaglutide, that will cause both of those, but also the useful thing is it's going to reduce cravings. So if it goes to your brain, and it's not the same feeling of fullness that CCK does, but it literally makes you stop like craving like food that you want to eat, even though you just ate.
Yeah, which is good.
That's so real.
Yeah.
Facts.
It works for a third of people, I think is what Brother Hunt said.
Yeah, something like that. And that's our fun regulation of stuff.
Well,
Digestion. Any questions?
no.
Beautiful work, Professor.
Good? Great.